So my talk is going to be about technical debt and why I think technical debt should be considered business debt. I'm sure many of you are familiar with the expression technical debt as something some people are fed up with. Some people are frustrated with that expression. Some people are trying to find an alternative to that. So I hope this talk is going to be interesting to any of you who are struggling persuading their managers about the importance of technical debt and why it needs to be tackled, and people who are not working in the engineering space. I don't think they are tonight. I think maybe understand what engineers are, what engineers mean when they mention technical debt. So let me introduce myself. My name is Andrea Laforgia. I'm a lead consulting engineer at Armakuni. Um, I like to say that I've been a coder for more than 40 years, as you can see from that picture, and I've been a professional coder for more than 30. Yeah. And I've worked with many different languages in many different industry sectors. There's a reason why I'm listing all that stuff there, and it's going to be clearer when I mention a specific aspect of technical debt later. Fun fact about that picture was taken by my mom in 1984, I think. Those are my dad's computers because my dad was a computer programmer. And I remember in those days when I had to tell my schoolmates what my dad did as a job, and I said he's a computer programmer, people didn't know what that meant because they didn't know what a computer was. I mean, that was the situation 40 years ago. I work for Armakuni. Armakuni is a consultancy. It's been on the market for 12 years. Very successful. We help companies embrace high-performing culture, which means high-performing engineering practices as well as ways to communicate, collaborate with various parties within the same company, and also stuff related to product management. We promote what we like to call the AKY, which is a compendium, a collection of engineering practices. And if you are curious about what we do, there's a link there on the website that you can look at. And if you are in need of someone who can come to your company and help your teams become high performing, then of course reach out. I'm always happy to talk about what my company does. So let's go back to the topic of this talk, technical debt. I'll give you a few seconds to digest this slide. I've had many conversations in my career with managers who were rushing developers saying, well, when are you done with your job? And some people were saying, well, I'm going to say, I'm still dealing with a technical debt from a previous developer you rushed. And the manager says, technical debt, what does that mean? And we always think that that managers are kind of stupid for not understanding what technical debt means. But in reality, often we engineers fail to explain what technical debt is in terms that they can understand. And that's because this is the notion of technical debt that we have, right? There's a value at the top, shining under the sun in the hands of the customer. And then there's a big mass of crap that supports that value, that is making our life miserable. There's lots of bugs, bad quality, lots of problems that are kind of impeding our process. And that's a shame because that's not really what technical debt meant originally. What we really mean by that is craft, right? Is the mass of issues that we have in our system, either because people were rushing, some people were not caring enough about quality, they were delivering under pressure, so it wasn't really their fault. Some people cared, some people didn't care, but the result is that this big mass of problems we have in our system. But that's not really what technical debt meant. Because if we look at the origin of the expression technical debt, that comes from Ward Cunningham, who is a pretty smart person in our industry. He is co-creator of the Agile Manifesto, co-creator of XP. He created the first wiki. And what he was trying to do at the time when he was working on this project, Why Cash, in early 1990s, he was basically trying to explain to his manager why we developers have to stop and refactor our work from time to time. Basically, what he was saying is we developers go into production with artifacts that reflect our current understanding of the business domain, problems we're solving, the customer needs, or even the tools we're using. And then as these artifacts leave in production, we are learning something. Whether we want it or not, we're going to learn. we learn about each of these aspects, business problems, domain, customer needs, and even the tools that we're using, because we might discover there's better ways of doing what we were doing. And what you were saying is basically, if we don't realign these artifacts to our new understanding of things, to new learnings, what's going to happen is similar to what happens when you take on debt, and then you fail to repay that debt, and so the interest grows. It drifts more and more and more, and it will eventually block us and impede our progress. So the metaphor is a bit, it's not perfect, but it works, right, in communicating why we need to stop and refactor things from time to time. And if you notice, he never talks about quality here. It doesn't say it's okay to go into production with crap, we'll fix it later. He only talks about the proper way of the proper way to think about our financial objects. So he talks about financial objects because why cash was a financial solution, but you can apply that to any domain. So it's about level of understanding, right? And this is something that other people have been vocal about, like Robert Martin. I know he's a controversial person, but his technical arguments sometimes are really good. And he was saying, true technical debt is never intentionally bad code, is related to features, not quality. Does not mean bugs and defects. So yes, the technical debt is about width and depth of features. So the scope of features is about the business domain, is about understanding the problems, is about understanding customer needs, mastery of the tools we use. It's not lack of testing. It's not cutting corners, not sacrificing quality, not quick and dirty hacks, known bugs and defects. And it's not about we'll fix it later mindset. So, okay, the manager now understands what technical debt means. Let's say they understand what we mean by that. They could still ask this very naive question, right? Why do we need that debt? Why do we need to incur that debt? Couldn't you do it right the first time? It's a question that some managers have asked me in my career. You could imagine that's like asking someone who's about to buy a house, why do you need a mortgage? Can't you just put all the money, you just give all the money to the vendor? And you might think it's a bit of a naive view of life. And if you ask that question for software, it's a bit of a naive view of software as well, right? This is like asking someone, do you have all the knowledge now to be able to do everything right? Do we have a crystal ball so we can look into the future and see everything the customer will need in order to implement everything perfectly today? Obviously, you can't do that, right? And this relates to what I was mentioning in my second slides, all those languages, all those fields I've worked in. Because that happens to all developers, right? As developers, we cross the industry and we land many different jobs in many different domains. And the retention in our field is very short. It's probably 1 to 2 years on average. And every time we land a job, we try to do our best with the knowledge in that specific field, right? We rely on domain experts and people who spent a long time, studying certain problems. But something is going to fall through the cracks, right? We're going to miss something. It's really hard to translate knowledge for someone else into code, into a program, to a software system. So we kind of assume when we do our job that we're probably not going to do everything perfectly. Something's going to be done wrong. And what do we do if we don't have all the knowledge up front, and then when we know that something's going to be done wrong? Well, we optimize our process for learning, right? Effective software development isn't about getting it right the first time. It's about having a process by which we can deliver something wrong and discover what's right by delivering something wrong in a fast way, because we don't want the wrong thing to be in the hands of a customer for too long. In an agile way, because every time we respond to whatever change we face, we don't want to break everything. We want it to be agile in the sense that changing is easy. We want to do it continuously because it has to be a deliberate practice of learning, and we want to do it safely. We don't want to put the customer at risk. So in other words, if we never reorganize whatever we've implemented to implement some features to reflect our understanding of those features, this is going to be like an interest that keeps growing and growing and growing on our debt, and it will eventually paralyze our system. Just to give you an example of this, what happened in my career, I worked in a place where we were dealing with legal entities. legal entities, so banks basically. And banks can own other banks, and those banks can be owned by other banks. And this concept of ownership was very blurry. So developers meant something, and the product owner meant something else. And I was a tech lead on this project, and whenever we had conversations, the product owner was scoffing, that's not really what I mean by ownership. And I said, no, we have to stop. We have to sit down. We have to get together. We have to clarify what we mean by ownership so that we can reflect that understanding in the code. And that might mean refactoring code, renaming things, renaming tables, renaming classes, renaming variables, whatever that means, in order to reflect that understanding. If you don't do that, the interest is going to grow. The drift is going to expand more and more, and we're going to be in trouble. So financial debt, we know, is not inherently bad, right? Financial debt is an enabler. We can buy a house, we can get an education through a student loan, we can start a business. Similarly, technical debt is not inherently bad. This concept of technical debt as a bad thing, it's not true. Technical debt is not bad. It's just debt. It all depends on how you manage that. Technical debt enables fast learning, right? Similarly to what we do with financial debt, where we borrow money, we do something with the money, we pay it back. We borrow knowledge money. What Cunningham says, we rush software out of the door. And bear in mind, by rush, it never means sacrificing quality. It means we do something high quality soon, we put it out in production, we get some experience with it, and we repay that loan by refactoring the program to reflect our experience. Now, this is why I think technical debt is the agile operating model. So if we really want to be agile, we have to accept that we have to take some debt and repay it soon, quickly, fast, safely, agilely, continuously. There's really no other way we can be agile if we don't accept technical debt as a normal thing that we have to incur from time to time. But let's not be romantic about this, okay? Too romantic about this. I mean, financial debt is not inherently bad, but is risky if we neglect it. We know what's going to happen, right? The two guys there are going to knock our door. Similarly, technical debt is not inherently bad, but neglecting it is risky. It can destroy our business. We can burn lots of money. And I'm going to give you a few examples of what happened in the industry when this type of debt was neglected and the problems it caused. Now, I want to caveat here that it's going to sound weird. It's going to sound different from the notion of technical debt people normally have. But it is technical debt. So, for example, Twitter. In the early days of Twitter, I don't know if any of you remembers that picture. That was the picture that was used when Twitter had problems. They implemented Twitter using a specific architecture like Ruby on Rails, and that was the right thing to do at the time. Nothing wrong with that. But as they understood more about how real-time communication had to be implemented, they realized the system they had implemented wouldn't scale. But they failed to address that on time, and that led to problems like downtimes, perception of reliability, limited growth, user trust. And those, obviously, Twitter survived all those problems, but many other companies failed. They went out of business because of those problems. MySpace was a big thing in early 2000s. It was basically like Facebook. And same thing, they implemented the system using specific architecture, and then that was optimized for pages, not social graphs. And then Facebook came about and obviously disrupted things for them. And they failed to read the situation. They failed to adapt their system to that new learning about their system. And basically, MySpace doesn't exist anymore. Flash. How many of you remember Flash? At the time, Flash was powering everything. Even YouTube was powered by Flash. Again, rich media applications, new technology came about. They failed to adapt to that. They went out of business. Well, not out of business, but Flash at least was not. It's no longer there anymore. Target Canada, they basically delivered this system to Canadian supply chains, borrowing from the US market. They could see that there were problems there. It was not working as expected. They failed to adapt to that situation. $2 billion expansion failed in under 2 years. Last example, Quibi. They created this mobile-only platform. They said, who's ever going to watch content on desktop, on big screens, right? Everything is mobile today. And then COVID came, bit of a black swan to be true, but they failed to adapt to this new situation, and that means that they went out of business in less than 6 months. They burned almost $2 billion. Now, I told you these are things that could be interpreted in different ways. So many people might say, okay, but this is the product people who were not diligent enough, right? This is the business people who didn't do their job well enough, right? But in reality, if you think about it, if we have a specific architecture that is not going to support whatever is happening in the technical landscape, whose responsibility is to raise that problem, right? A person working in the business area, a person working in product, they might not have the skills to understand the impact of that technical structure on the business. So it's us, engineers, who need to surface that in some way, right? So what can we do to do that? I'm going to give 3 little pieces of advice, but this could be a very, very long list, of course. But I think this is a good starting point. Use a single backlog. What many companies do, they create 2 backlogs, one for business work, one for technical debt. And then what developers do is say, okay, next sprint, we're going to take 80% from the business backlog and 20% from the tech debt backlog, right? Sounds perfect, right? In the long term, we're gonna fix all the tech debt. And that never works because the business work always takes precedence over the tech debt works, which is always very obscure to product people. They don't really understand what that means, right? And it degrades this approach degrades and fails in the long term. I've seen it a billion times fail. So create a single backlog, right? It's all work. It's one work stream. Second advice is work incrementally and iteratively in short cycles. Now, many people might think, well, we do that, right? We adopt Scrum, we do sprints. But the reality is most teams adopting Scrum, what they do, they plan at the start of the sprint and they plan a set of tasks. They don't define a sprint goal. Then they work on their stuff, blah, 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 blah. They get to the end of the sprint, they move everything to done. Well, not everything. Some stuff is carried over, who cares? They do a quick demo with stakeholders. Some are there, some are not there. They tick everything done. Boom, done. Plan the new sprint, right? That's Scrum theater. That is not an agile way of working, right? The proper way of doing that will be to deliver continuously to stakeholders. At the end of the sprint, what you do, you have a review, which is a working sessions where you nip things in the bud, you prevent technical debt, you discuss stuff that works and doesn't work, and then you have feedback to basically tackle technical debt as early as possible, right? And do the right thing. Fix whatever misunderstanding, whatever problem you find as early as possible. And then you can plan the new work. And final point, speak the language of the business. I think that's the most important thing. Because even if we create a single backlog with items that relate to technical debt and items that are just new work, if they speak different languages, they are still going to be cryptic to the product people. Speak the language of the business is really, really important. And that's an effort that developers have to make. I'm going to give you a couple of examples of what I mean by that. This is a typical ticket that we see in Jira backlogs, right? It mentions job library, authentication modules, token validation standards, middlewares, stuff that a product owner doesn't really understand. They might get a glimpse that there is a problem there, but how serious, how severe it is, they don't know. They might need to ask lots of questions to understand the intricacies of this, if they are really diligent. Sometimes they just deprioritize the work, goes to the bottom of the backlog, and who cares? There's a way of rewriting a ticket like this to highlight the business risk associated with the work. So we could mention the risk of login failures, security incidents, risk of user login failures, potential security breaches, customer-facing outages, non-compliant, lack of compliance with security requirements, and so on. And we can even add sections to bid tickets to highlight what we think will be the business impact. We might make things catastrophic here, But this is a starting point for the product owner to understand the problem, discuss the problem. Remember that one of the points of writing cards is to trigger conversations with whoever is involved in the work. Second example, migrate background jobs from Redis queues to Kafka. What is Redis? What is Kafka? I'm a product owner. I didn't know anything about that stuff. Job queue systems, high throughput, latency, retries, job producer, consumers. It's language I don't understand. As much as I'd like to understand the importance of this work, I don't have enough elements. So there's a way of rephrasing this as well, right? We can say, okay, we want to ensure a smooth user experience, give traffic spikes. We mentioned peak usages, delaying processing user actions, inconsistent behavior for users, slow responses, and blah, 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 right? So we give hooks to the product owner to understand what the impact of this work. So, key takeaways. Then I'm going to shut up, I promise. Technical debt is not something bad, it's an enabler. We borrow knowledge money frequently, agilely, safely, as I say, the second point, and we pay it off each time. It's an operating model. We release, we learn, we adjust, we repeat, fast, agilely, continuously, safely. And technical debt is not just technical. Any suboptimal technical structure we consciously produce has business risk, and that business risk needs to be surfaced and monitored all the time. That's it. Thank you. Yes, exactly. So the problem is exactly, but that means that's why what I'm suggesting is not just putting everything in a single backlog, but also speak the same language. Because if I can recognize, or better, if as a product owner I don't understand what that ticket means, I'm gonna deprioritize that because I'm in a rush. I need to deliver, right? You know, everybody's under some sort of pressure. So my advice is always to make sure that they can see the importance of that ticket so that they know then that work needs to be prioritized, right? In reality, we need to rely on conversations a lot, right? We need to have I see tickets as triggers for conversations, right? So if I put words there that raise alerts in your head, then that is something that's going to trigger a conversation. You're going to come to me and say, look, I read that we might have like an outage here. What does that mean, right? And that creates a conversation between us. And if we talk about that, you can understand the importance of that, right? And prioritize it correctly. It's all about making sure that it doesn't disappear because people don't understand what that means. Exactly the problem you were saying, right? When they deprioritize it because they don't understand the importance. So obviously everything is contextual, so it depends on the context you're in. You might be working with people who understand the importance of those of that work, right? I would imagine that if it's just a matter of saying we want to upgrade the library, we want to have like a small ticket to do that, then maybe the product owner is going to be smart enough to understand that work, right? I'm just assuming that they will be. There is a level of work, level of refactoring that you should be able to do without asking for permission, right? Ingraining that stuff into your ordinary work, right? The merciless refactoring that XP mentions, right? For something bigger than that, that requires proper planning, then we need to make an effort to explain those things in business terms. What does it mean for the business? Even if it's just upgrading a library, what does that mean for us, right? Even if it's just one or two words to say this is gonna make, I don't know, the system safer, or it's gonna make, the process faster, or whatever. You know what I mean? You know what I mean? Something that gives you a hook to light up a bulb in the head of a product owner, right? To facilitate conversation. Yes. So I mean, the way teams work is very complicated at times, right? So it doesn't end there. It's not that is not a magic recipe. It kind of assumes that teams have some sort of autonomy, in the way they work. So Obviously, if you have to ask permission for every single bit of work you do, and you have to justify that, it becomes really exhausting and frustrating. So it really depends on what's your relationship with product. If you feel like this is one of the things we do as coaches at Armakuni, when we realize that teams have to ask for permission for every single thing they do, that's a dysfunction. That's a dysfunction that needs to be addressed. And we help by that requires conversations with the management and say, look, your teams have to be a bit more autonomous, independent. It's hard, but I get where you're coming from. It's a problem that I see all the time. And I'm not saying it's easy to do this stuff. It requires conversations, it requires having hard conversations sometimes with people who are in charge and saying, look, you have to relinquish a bit of that control, give it in hands of the team, because you're going to get better results. It's very anti-intuitive for people who like control, but it's part of solving this problem is also having that kind of conversation with the managers. Sorry, I could talk for hours about this stuff. But